Okay, good morning, dear friends. Like, I'll be talking about an article today regarding lateral aligners. I've been trying to do it live, but due to some time constraint, I'm not able to commit, so I'm just playing the recorded version for it. For you guys, you need to understand exactly how to plan an aligners, what's going on to be the consequence of a good aligner planning. Let me just make you clear that aligners are basically digitally driven devices. The digital data are recorded in the form of STL with the help of internal scanners, and as a result of which it develops STL files. The STL files are sent to the third-party software, and then there occurs the segmentation. You have to mark the tooth, and then the segmentation happens. The software has to really understand what is the tooth number, the tooth size, the mass, the volume, the surface area, and its delineation from the gums. Most of the scanners don't have the property of delineation. So this helps us in this. Now, the accuracy of delineation will help us to understand that how we can treat and plan a case of orthodontics with the help of software and cause the tooth movement. It's very easy actually, but once if you understand it, the moment we don't understand it, it becomes difficult for us to recognize it. So, like wherein we have to decide about the accuracy of the softwares. In the accuracy of softwares, we have to consider that aligner software, which is highly sensitive, needs to regulate the data. What happens exactly in this? Wherein once we create the still files of the internal cavity, we send it to the third-party software. In that, they do the rest, and we have to again understand and actually identify the tooth issues and all. So, what happens actually? The software has to be precise. The caseling setup, which was done manually earlier, will be done in this automatic segmentation method. The more clarity the segmentation is, the more easy for the tooth movement to happen. Yes. Now, many softwares, in order to make it very much more accurate, they have taken the CB instead inputting the DICOM data, the CBCT. In that, what we find that the CBCT data gives the idea about the bone and the root. So it's not only a manipulation of the tooth structure in the surface level, it is going beyond that. And we are going to the root level also. That's the beauty. Now, I'll be discussing this article based on the critical appraisal of the article to understand how it's going good. Now, when we saw that your virtual setup creation and ordering appliance fabrication are more directly linked. So I've been trying to read these articles. So about this, it is a part of Spring Nature, and it is published in Curious Open Forum. So latest article of till date, and it is open access and is an original type. Open access is very much important for low middle income countries having to work back so that we can be able to understand the things very clarity. Now, if you consider the precise, so there's various software packages that facilitate the building of virtual setup. The performance of the software package, the automated tool segmentation, has not been widely studied. That's the policy that if you don't study the software improvement, it becomes a tough job for us. And we can't assist an orthodontist with this. We need to understand the tooth movement, take the consent of an orthodontics and plan the aligners and then get it done in a most cost-effective manner. That's the role of a once the accuracy decreases, there is some basic landing cost which comes in the form of penalty to the patient. How? So let me explain to you that the few material methods of the article that the scans were taken with internal scanner. The internal scanner is of rupees they have taken. A good one from China exactly. economical one for study purpose also. Most of the accurate scanners are ranging from a various market players and that, but let's not discuss about it. The baseline they have taken Runes, and the scans were stored and input as STL files. They have taken the software, the Master Studio and 3-shape ortho analyzer. Subsequently, the digital photo underwent alignment in both the software application. That's the property of the software. They will align the photo STL files and all in the maxillary magnetic oriented. The digital images were automatically segmented by Mastro and 3-shape. That's a feature of the software. They automatically segment it. As a result of which, the accuracy of tooth segment was assessed. So you know what? There's an independent t-test with a significant level of, like as usual, the probability value less than 0.04%, and the statistical significant difference in two software were calculated. What was the result? The total number of teeth segment by both software programs utilizing 12 interval scans was 336 for each group. Sounds good. Successful identification of the tooth segment was 98.21 for 3-shape software and 98.8 for Master software, proving it to be more accurate. There was no significant difference in the accuracy of determining the tooth segmentation between the anterior and posterior teeth. So the software is clever enough, intelligent enough, artificially again to do it between two groups with a p-value 0.523. So there is no significant difference. The result is as such. What can we conclude out of it? There was no statistical difference between the two program softwares, and both demonstrated high success rate for auto tooth segmentation. Although both programs had excellent success rate, Master 3 performed more accurately than 3D Authority. This is based on the study population curious. You guys, we have to do that research with various open softwares, closed software, subscription software, so that we'll be able to find an answer to it. Thank you. Expecting more results.